Hi, and welcome to Friday, September 4th. This is the end of week 6. And today we're going to take a look at the Pythagorean identities and how we can use them to simplify trig expressions. Okay, so the last time that we talked, we learned about the reciprocal identities. Okay, these were the three reciprocal, these are the three reciprocal identities. So all that means is if I want to get cosecant, if I flip sine, I'm going to get cosecant. That's what that's telling you right there. Okay, the next one says if you flip cosine, you're going to turn it into a secant. And if you flip tangent, you're going to turn it into a cotangent. Right? Then the other identities that we learned about was another way to get tangent. We know tangent is y over x, but now since we know that y is the same as the sine, we can replace the y with the term sine, and we can replace the x with the term cosine. So if you know the sine and the cosine, you can use this to figure out the tangent. And that's exactly what we're doing in this first example here. All right, so it says find the exact values using identity when the sine and the cosine are given. So we're starting off knowing what the sine is and what the cosine is. So we got 4/5 for our sine, and we got negative all right, you're told that sine is positive 4/5, so sine is positive, so it's positive there, it's positive there. Cosine though is negative, so cosine is negative in quadrant 2 and cosine's negative in quadrant 3. So the only one that's shaded both colors is quadrant 2. So that's how I know when I wrap t around this, when I take a number line and I wrap it around the unit circle, or the circle here, it's going to end somewhere in quadrant 2. Now the question is, if you just know these two things, how do you find out the other remaining trig values? Okay, well, let's start with the ones that are real simple, the reciprocals. Okay, so if I know the sine, I flip it and I got my cosecant. So that's going to be 5/4. If I know my cosine, I'm going to flip it and get my secant. So that's going to be negative 5/3. Now all that's left is tangent and cotangent. Well, that's where we use this quotient identity. So to get the tangent of t, I'm going to take the sine, which is 4/5, and I'm going to divide it by the cosine, which is negative 3/5. So to divide fractions, you multiply by the reciprocal of the denominator. So that's going to be 5/3. So the 5's cancel, and I've got 4 times negative 1. It's going to be negative 4 over 1 times 3 3. And there's my tangent. Now I'm going to flip that to get cotangent. Negative 3/4. And there are my values. All right, so just to review, what we did first was we figured out what quadrant we were in based on the signs here, which was positive and negative, and we came up with quadrant 2. Then to get the secant and the cosecant and the secant, I flipped sine and cosine. To get the tangent, I used this reciprocal identity, sine divided by cosine, and simplified it. And then to get cotangent, I flipped the tangent. So that's the first part. When you have a problem where you know both the sine and the cosine. All right, the next part we're going to introduce is the Pythagorean identities. Now, the Pythagorean identities are related to the Pythagorean theorem. Now, back in geometry, when you learned about the Pythagorean theorem, if you had a right triangle and you take the legs, so this purple side here is a leg, and this purple side is a leg. Okay, so if you took the length of the leg and you squared it, and then you took the length of the other leg and squared it, you would get the length of the hypotenuse squared, which in this case is 1 squared, which is 1. So our Pythagorean identity, when you learned about the Pythagorean theorem, it was a squared plus b squared equals c squared. All right, so in this case, since it's a unit circle, this is the radius of the unit circle, so its radius is 1. That's the hypotenuse of our right triangle. So if we take out the letter x and we replace it with cosine, because x and cosine are the same thing, then we can say that the cosine squared plus the sine squared is also equal to 1. All right? So I just replaced the y with sine and the x with cosine. So what that allows you to do is, if you look at this example right here, this is an example of the Pythagorean identity. Sine squared of whatever angle, doesn't matter, as long as they're the same, plus the cosine squared of that angle, that's going to equal 1. Okay, and it wouldn't matter what's in there. If I had sine squared pi over 6 plus cosine squared of pi over 6, that's going to equal 1. If it was a radian, other than like without pi's in it. So if I said the sine of square root of 0.7 plus the cosine squared of 7/10 of a radian, that's going to equal always 1. That's what the Pythagorean theorem is saying, or the Pythagorean identity. Okay, now there's 2 more identities that are related to this one. The way you get the first one is that you take this formula, the Pythagorean identity, which is this one that I'm writing, okay, and you divide each side of the equation by cosine squared. So I'm going to divide this side by cosine squared plus this by cosine squared and 1 by cosine squared. All right, now, so what I did was I just divided everything by cosine squared. Now, if we go up to our identities here, okay, cosine over cosine, they're the same, so that's just 1. Plus, now if you look at sine over cosine. Sine over cosine is tangent. These are squared, so this is going to be tangent squared. Okay, 1 over cosine squared. Let's see, there it is. There's 1 over cosine. So if that's squared, then that's squared. So this would equal secant squared. And that's your second Pythagorean identity. And then the third one is you do the exact same thing, but now you divide everything by sine. So if we take our original Pythagorean identity and this time divide everything by sine. Okay, so we're going to go through, divide by sine squared. Divide by sine squared. Divide by sine squared. All right, so what's going to happen there is cosine squared over sine squared. Well, if these are squared, then the cotangent squared. So that becomes, this first term becomes cotangent squared of theta plus sine squared over sine squared is 1, and 1 over sine squared. Let's see, 1 over sine is cosecant, so 1 over sine squared is cosecant squared. And that is your third Pythagorean identity. So these identities we use quite a bit, especially the cosine plus sine squared. These other two, not as often. Okay. All right, so if we look at this second example here. All right, the second example looks close to what this Pythagorean identity is, except it's in a different order. So what I want to try to do is take this identity, which I wrote over here, and rewrite it so that it looks like this. Now, a few minutes ago, this was a plus sign. That was a mistake, so I changed it to a it's supposed to be a minus. All right, so if you took this original identity and I moved the tangent over to the side with the secant by subtracting it, these cancel and I get 1 is equal to the secant squared minus the tangent squared. And now that looks exactly like my expression. So if this is equal to 1, then that's equal to 1. All right. So those are the Pythagorean identities. This is one way that we use them. Okay, and you know that you're going to use them because what you look for is, do both of these terms, are they both squared? And that's usually a hint that you're somehow going to be using a Pythagorean identity. All right, so here's our three identities. Now, what makes these handy is if I just know the sign. So before up here, I knew the sine and the cosine, and then we went through a process and we got everything else. Well, what the Pythagorean identity says, you know what? You don't need to know two of them. If you know just one of them, you can get all of the rest. Okay, so in this example, all I know is what the sine is. And then the question's asking me, well, if you know that sine, what's the cosine? Well, this tells you how they're related. If I know sine, I can figure out cosine. So to do that, I take my Pythagorean identity, sine squared plus cosine squared equals 1. And I'm going to take out sine, and I'm going to replace it with 7 over 10, and I'm going to square it. Now, square 7 over 10. So 7 times 7, 10 times 10. Now, subtract 49 over 100 from both sides. And I get cosine squared, so I'm getting closer. Okay, now I got to do 1 minus 49 over 100. Well, 1 would be the same as 100 over 100 minus 49 over 100, and that's going to be 51 over 100. Now take the square root. Square root cosine squared, square root 51 over 100. Okay, so the square root of cosine squared is just cosine. So that exponent of 2 and the square root sign, they undo each other. Okay, to do the square root of a fraction, do the square root of the top and do the square root of the denominator. Okay, well, root 51 can't be simplified. It's not a perfect square, so I'm going to leave it root 51. And the square root of 100 is 10. So there is my cosine. It's root 51 over 100. So we use the Pythagorean identity when I just know sine and I want to get cosine. Or, in this next example, I just know cosine and I want to find sine. Okay, so it says find sine given that the cosine is negative 7/10 and the angle is between pi and 3 pi over 2. So on our unit circle here, on our quadrants, 0, this is pi over 2, this is pi, this is 3 pi over 2, 270 degrees, and this is 2 pi. So this right here says the angle is bigger than pi, but less than 3 pi over 2. So we know that we're working in the third quadrant. So when I'm done with this question is asking me to find the sine. I think I made a typo here. It should be find sine. Okay, when I write my answer, I'm going to have a negative. And the reason I know that is because in the third quadrant, sine is a negative number. Okay, so to get that now, we're going to put it into our Pythagorean identity. So we got sine squared plus cosine squared equals 1. So I'm going to take out the word cosine and I'm going to put in the number negative 7/10 squared equals 1. Okay, now I'm going to square negative 7/10. So negative 7/10 squared is positive 49 hundredths. So positive 0.49 equals 1. Okay, now get sine by itself. So subtract. Okay, and I get sine squared of the angle equals, and this is going to be 1 minus 49 hundredths. Okay, so I get sine squared theta equals, well, when you subtract those, 1, take away 49 hundredths, I get 0.51. And now take the square root. And when I square root that on my calculator, I get 0.714, and I think we're going to round to 2 decimals. So I'm going to say that's approximately 0.71. Now, when I put it over here, it's going to be negative. And then there's my solution. Because in the third quadrant, sine is negative. Okay, well that takes care of this section, and you have an assignment. It's going to be Math Excel 17, and this is Tuesday when it's due, Tuesday at midnight. So enjoy your long weekend, and I'll see you next time. Bye-bye.